Welcome to Solving Time Value Money Problems with the BA2 Plus Financial Calculator. This is the third in a four-part series designed to help you get the most out of this powerful little device. In this video, I'm going to show you how you can solve any uneven future cash flow problem with the cash flow worksheet. And when I say an uneven cash flow problem, I mean a problem that has cash flows that look like this. Some of your cash flows may be negative, some may be positive. They may start right away, they may start later on, won't matter. The cash flow worksheet can deal with all of those. And we're going to be able to do this with a relatively modest cash flow worksheet, which only has 24 cells in it. Although we can extend those cells if we use annuities. And I'll show you how when we get there. The cash flow worksheet has its own set of dedicated keys, and you can see them in the middle of the calculator there. The first key is the CF key. You use that whenever you call up the cash flow worksheet. So you call it up, you clear it, and then you start to populate it with values. And once you get all your values in, you ask it for the operation that you want. Do you want the net present value, or do you want the internal rate of return? Negative signs are going to count. Unlike the previous two videos where minus signs were mathematically irrelevant. Not with the cash flow worksheet. You can see here in the diagram I have above, two of the cash flows are negative, and we have to take those into account, so the negative signs do count. And finally, we can also use the cash flow worksheet to solve annuity problems and bond problems. So this is really a very powerful worksheet. It can do uneven cash flows, it can do annuities, it can do bonds. It's well worth your time to learn. So we begin with a cash flow problem where we have a $600 expense today, and that's going to return annual cash flows of 180, 250, 153 times, and 100. And what I want to do is show you how you populate the worksheet, because the worksheet is very different than any worksheet you've used so far. First of all, we call it up, CF. Then we hit the second key, so now we're going to clear it. Now the clear worksheet key is not the clear TVM key. The clear worksheet key is the one all the way down in the lower left corner. That's the CE/C key. All right? And if you don't do that, you could be left with some values that are far down in the worksheet that you haven't thought about. So you want to be sure you clear it every time. All right. Next, we want to put in the $600 expense today. And the very first row is today, and it's always the zero row. So we put 600 in, we change it to a negative, we then hit the enter key, that saves it to the worksheet memory, and then we hit the down arrow key, which will serve as a shift key, so that will shift us out of that zero row and into the first row. Okay, so 600, negative, enter, shift. We're down into the first row. Now, the first row is one of the middle rows, and the middle rows are all different in that they have both a frequency and a room for the value in the same cell. So you put the value in first, then you put the frequency in. For example, the next number that we have is 180. So we put 180 in, we hit enter, shift. Now, we don't shift down to the next row. What we do is that moves us down to the frequency component of that row, and we use the 180 once. Now, there's a 1 waiting for us. The calculator is going to assume that all the numbers that we put in are only going to have a frequency of 1, so it puts the 1s in for us. We see the 1, so we shift out of it. So really, to get out of that first row, we put in 180, enter, shift, shift. We're down to the next row. Same thing with 250. We put 250, enter, shift. We get down to the frequency component. We see a 1, it's okay. We hit shift again. That takes us down to the third row. We get to the third row, we see 150. 150, enter, shift. We get down to the frequency component, and we don't like the 1 because we have 3 150s. So we override the 1 with the 3. So 3, enter, downshift. That takes us to the next row. And the next row is really the row that has the very last entry in it. When we get to the last entry, we have to treat that a little bit differently. So we get to the last row, and we put the 100, enter, shift down, and we stop. And say, what do we want? Do we want internal rate of return, or do we want the net present value? If we want an internal rate of return, all we do is hit IRR compute. And there it is. You have an internal rate of return. If you want the net present value, let's do that fourth row over again. If you want the net present value, you would put 100 in once. You put 100, enter, shift down, stop. You want the net present value, so you hit net present value. Then the calculator doesn't know what net present value you want. So I just throw a number in, 10%. There's no reason for having it there other than I just had to put something in. So I put 10 in, and then I hit compute, and then I get my answer when that happens. So you really have three regions. Your very first cell is today, and once you put the value in and save it and shift it, you get into the next, you get into the middle cells. Middle cells have room for values and frequencies. And the very last cell has a room for the value itself, and you can go directly to the operation, or you can, we'll see an annuity in another problem later on where it's a little, we can actually change the frequency of that last one. But for now, this is how we want to think about the last row. Now, all of this is done with rows that, or with a worksheet that has 24 rows or 24 cells. But look, we have 7 values in the sentence at the top of the page, and yet we are only in the 4th row. So if we had used some more annuities in the middle, we could have saved some cells, and we could put a whole lot of numbers in the worksheet. Let's work some problems. So we're going to start with an uneven sum problem. $500 expense generates annual returns of $183,175. We're going to discount them at 4.5%. I draw by diagram or part of it. Now I'm going to call up my cash flow and clear it. CF second clear worksheet. Don't forget that clear worksheet is all the way down here in the bottom part of the cell right there. Okay? CF second clear worksheet. All right, now we have a $500 expense. So we put the 500 in as a negative number, enter, down. That's today. So now we're in the next row. And the next row has 180. That's our first value. So we have 180. We hit enter, shift. We find a 1 waiting for us that the calculator put in, so we hit shift again. We get to 300. We hit 300, enter, shift. We find a 1 waiting for us, shift again. So if you have single cells, you can, single values, you can put in like 300, enter, shift, shift, and move to the next one. But now you get to the very last one, be careful. 75, enter, down, or shift rather. And then the next thing you have to do is ask, which operation do I want? And in this case, we want the net present value. So we put the net present value in, 4.5%, enter, shift. But nothing has happened yet. Calculator hasn't done anything. It's just populated the worksheet, and it said that, okay, we're going to discount everything back at 4.5%. So in the next step, when I hit compute, here's what happens. Those 3 values are discounted back at 4.5% each, and they are subtracted, or they are applied against that initial outlay of $500. And you can see we have a net present value of $1,269. Let's do it again, only instead of asking for net present value, let's do just present value. And we'll just drop the 500 off. So all of the entries are the same as the previous problem. But pay attention here that what we have to do is put a 0 in for today. We always have to put an entry in for today. Either we put a number in, or if we're looking for the present value, we don't have anything there, we put 0 in, and then we finish the problem. Now the internal rate of return. All right, $500 expense, you have 3 annual cash flows. What's the internal rate of return? Draw our diagram, clear our calculator, call it up rather, then clear it. Now we put in 500, negative, enter down, we're now out of today. Okay, that's today's 500 negative. Then we have the 180, enter, shift, shift. 300, enter, shift, shift. 75, enter, shift, stop and wait. What do you want? You want the IRR, so you hit IRR. Now, nothing's happened yet, but as soon as you hit the compute button, what it's going to do is it's going to discount those 3 terms back at different discount rates, hoping to find a sum of them, a sum of their present values equal to the $500 expense. So we hit the compute button, and we discount those 3 back, and they're discounted back at a rate that would offset the initial outlay, and there's our internal rate of return, 5.97%. That's a good definition for the internal rate of return, the discount rate that causes an investment's present value to equal 0. Kind of like that one. Let's go on to 4. Net present value, uneven sums. Okay, now we have a $7,000 expense, and there's your annual cash flows. Okay, what's the net present value discounted at 20%? So how is this problem different than others? Well, it has the annuity in the middle, okay? So we set it up, and we call up our worksheet, we clear it, and the next step is to put the 7,000 in as a negative number, enter, shift down. That takes us out of today. The next number we have is 3,000. We use it once. 3,000, enter, shift, shift. We accept the 1 that the calculator has waiting for us for the frequency. Now we have 5,000 4 times. So we put in 5,000, enter, shift. And instead of the 1 that's waiting for us, we overtype it with a 4, enter, shift. So we can overtype that frequency at any time. It's just that the calculator thinks that most of our entries are probably going to be unique entries, so it puts the 1 in for us. But we can make the adjustment if we need to. The next number is 400. Enter, shift down, stop. It's the very last number in the array. So now we want to ask for the net present value. Click on net present value, and when we do, it's going to say, what discount rate do we want? We have to put in the 20. And then we hit enter, shift. Nothing's happened yet, but as soon as we do this, what's going to happen is all of these cash flows are going to be discounted back at 20%, and they're going to be netted against the $7,000 expense that we had in the first place. Hopefully we have more than $7,000. So hit compute, everything discounts back, and you can see that we do have more than $7,000. Once we subtract the $7,000, we are still left with $7,626. Number 5, internal rate of return, uneven sums. All right, so let's see. This looks like the same problem we had a minute ago, but now we have the internal rate of return. So what I'm looking for is the discount rate that is going to discount all those cash flows back at a rate that will give us a present value exactly equal to that $7,000 outlay. And there it is. So all those cash flows have been discounted back to exactly $7,000, and they had to be discounted back at 55.63%. Now, when you do this problem, if you are working along and you do it in your calculator, you're going to find that your calculator is going to pause for just a minute while it finds the internal rate of return. That's because it's experimenting with the discount rate. It might say, okay, I'll try 10%. Oh, 10% is too low. Try 20%. Too low. 30%. Too low. 40%. Too low. 50%. Too low. 60%. Whoop, too high. 52%. Too low. 67 or 57%. Too high. 55%. Too low. 56% too high. And it keeps doing that, narrowing it down until it gets the present value of all those sums equal to the original outlay of $7,000. That's why you see the calculator pause while it works the internal rate of return. Let's compare the time value money worksheet with the cash flow worksheet. So this time we'll do an annuity. And back in one of our earlier videos, we had a 4-year annuity that looked like this. And we're trying to find its present value. Now, if I'm using the time value of money method, or the time TVM worksheet, what I would do is clear it, and using the user manual, I would second begin, second set, till I find end in the display, then I hit second quit. Okay, now I can do my problem. 100 negative for and the 9, and then I would get the present value. Or I probably would do it this way with my shortcut. I would simply say second reset enter, then put the 100 in as a negative number, the 4 in for the n, the 9 for the interest rate, and compute the present value. If I were to use the cash flow worksheet to do the same problem, because the cash flow worksheet can be used for annuities, okay? I do this. I call it up, clear it. I put 0 in for today because I don't have anything in there for days. 0, enter, shift down. Then I put 100 in, enter, shift. I have it 4 times. 4, enter, shift. Then I ask for the net present value. 9, enter, shift, compute, and I get 323.97. Exact same answers as we would get with the TVM worksheet. We're going to do the same thing, only with an annuity due. All right, so I'm going to use the time value money worksheet method, user manual method. There's my annuity due. Those 4 payments are shifted back to the beginning of the payment period. And you can see it's a 4-period annuity, but the fourth payment occurs in the 3rd period. Now I hit second clear TVM, second begin. Now I can start programming. Second set, second set, second set, until I find begin in the display. Then lock it in with second quit. Then I hit 100, put my numbers in, and I get down to my interest rate, and I stop. Well, the reason I stop is because we have compound interest within the year. And as far as the TVM worksheet is concerned, that interest rate key is only for single interest. So we have to find an effective rate. So I work out the effective rate this way. 9% divided by 4, because it's quarterly, plus 1, raise it to the 4th power, because it's quarterly, subtract the 1, that gives me the decimal equivalent of the interest rate, multiply it by 100, because I need integers, and once I get 9.31 in the display, I simply tap the interest rate key, and it gets saved into memory. Now I can finish my problem. Compute the present value, 351.74. Let's see if this is any easier with the cash flow worksheet. So I call it up and clear it. I put the 300 in, or I put the 100 in rather, in today, and enter shift down. Now I put the 100 in 3 times, because that's the middle cell. I put 100 in 3 times, and now I need an interest rate. And guess what? If I'm using compound interest using the worksheet, I still need the effective rate of interest. So I still have to work out the effective rate of interest at 9.31%. Once I do that, I compute, I get 351.74. Same answer. Number 8. Okay, we'll compare the TVM versus the cash flow worksheet again. And let's see, I want to know, I have a 4-year ordinary annuity, and I'm looking for the internal rate of return. So if I'm using the TVM worksheet, I use my shortcut, second reset enter, ordinary annuity, right? Next, put in my 3 numbers and ask for an answer, 12.59%. If I'm using the cash flow worksheet, it's almost as easy. I call it up and clear it. I put the 300 in as today's value. I put the 100 in 4 times. I hit the IRR, and then I hit compute. Hit compute. Hit compute, and it'll get there, 12.59%. Now, here's one thing that's kind of interesting between the TVM and the cash flow worksheet. Whenever you're working with the cash flow worksheet over here on the far side, you always ask for the operation first, the IRR, then you compute. But whenever you are doing it with the TVM worksheet, you say compute, and then you ask for what it is you're looking for. So it's backwards. And if you are doing the worksheet and you get it backwards, guess what? You get to populate the worksheet over again. Uneven sums. Okay, so now I want to find the future value of this sum. Wow, find the future value. But my cash flow worksheet is designed for present value. How do I find the future value? Well, I do it this way. First of all, I set the calculator up. I find the present value of the cash flow. It is 14,626. Once I have the present value of the cash flow, I treat that as a simple single sum, compounded ahead with the TVM worksheet. So I can use the cash flow worksheet to discount all of these uneven sums back to a present value. Once I get that, then I can treat it as a single sum, and then I can multiply that ahead. Pretty easy. Number 10, bond valuation. So now we haven't talked about bonds yet, but so I may mention some numbers here you're not familiar with. But we have a $1,000 5% bond. That means that that bond is going to pay $50 a year, but it pays it semi-annually. So it's going to pay those interest payments out in $25 amounts every 6 months. All right, it's a 30-year bond. So right here in my graph, you see I have 30 years. But there's actually 60 compounding periods in the problem. So let's do a bond valuation with the worksheet. Clear my worksheet. I put 0 in today because there's nothing there. I put 25 in. That's the coupon payment. But look, I only have 25 of them. Okay, I only have 25. I have 25. I only have 59 of them. Excuse me. I only have 59 of them. And the reason I only have 59 values of 25 is because that last 25 is lumped in with the final principal payment. So that comes out to 1,025. But the difficult thing you have to remember here is that if we're discounting this back at 7.2%, that's an annual yield, and this is semi-annual compounding, so I have to use semi-annual interest. So when I put the interest in, I put 7% divided by 2 equals enter, and then I can compute my answer. And my answer comes out to 731.05. And that takes us pretty much to the end of the things that we can do with the cash flow worksheet. As you can see, we can do a lot with it. You decide what you want. But for a final recap, remember that the cash flow worksheet has a beginning, always today. You always have to put something there. It has middle cash flows, and those middle flows have 2 component parts. One for the value itself that you are putting in the worksheet, and one for the frequency. And then when you get to the end, what you do is you request one of those operations. And you do it differently than you did it for the previous TVM worksheet. In the TVM worksheet, you said, compute the present value, compute the interest rate, compute the internal rate of return. What do we do here? We say internal rate of return, compute. Net present value, compute. It's backwards. Don't forget that 0 for today. And, you know, there's a lot of things you can do with this. You can find present value, you can find future value, you can use annuities, you can use just about anything you can think of. So that takes us to the end of this presentation. And if you find it useful, you might want to take a look at the 4th video in this series, which deals with bonds and the bond worksheet, where I assure you that the bond worksheet is completely different than this one. Absolutely completely different, but very interesting as well. So, see you in the next video.